Good day, grade 12. Today, we are going to do chemistry, which is physical sciences, which is your paper 2. My name is Furuani Mashapa. We are going to do chemistry, like I said. The objective of the lesson, as it's been given in the exam guideline, you are supposed to define the rates of reaction. You are supposed to calculate the rate of reaction. You are supposed to list the factors that affects the rates of reaction. You are supposed to explain in terms of collision theory. That is very important because you will need the collision theory to explain how these factors affect the rates of reaction. And grade 12, that is your examination question that you must remember. You are supposed to answer the question and interpret the data. The data can be in the form of table or graphs. So in other words, you cannot say, I've done the table and I'm not going to do the graphs. So the two goes hand in hand. And you are going to define positive catalyst. Why positive catalyst? In our curriculum, we only deal with positive catalysts because we are only going to deal with the factors that affect the rates of reaction, because the negative catalyst doesn't speed up the rate of reaction. Instead, it slows the rate of reaction. Objective of the lessons, and continue, then you are going also to interpret the graph, but this time you are going to interpret the Maxwell-Boltzmann distribution curves. Now, you cannot define or talk about the rate without knowing what is chemical reaction. Chemical reaction is the process in which the reactants, you have done the reactants, the equation in grade 8, 9. So now you are now going to know what is chemical reaction. Chemical reaction is the process whereby the reactants are converted into the product. And this product that is going to be formed will have got its own chemical and physical properties. What happens during chemical reaction? During chemical reaction, the existing bonds that are found between the reactants are going to be broken down and the new bonds are going to be formed. But what makes these bonds to be broken? In order for the bonds to be broken, the particles must first collide. What does that mean? It means the particle must move in order for them to collide. And when they collide, they must collide effectively. And after they've collided effectively, they also need to possess sufficient energy. And this energy, in grade 11, you regard it as activation energy. What is activation energy? Activation energy, it is the minimum. In the exam, you leave the word minimum, you get 0. Because definition is 2 or nothing. So you define it as activation energy is the minimum energy required to cause effective collision. So in other words, what does that mean? It means in order for the effective collision to take place, the particles must have got sufficient energy, and that energy, we call it activation energy. Now, let's define the rate. Rate of reaction is defined as the change. I've underlined the change. I've also bolded it because it's very important. For the rate, to define the rate of reaction is the change in concentration of the reactants or product per unit time. So there are very important things that you need to remember. In order for the rate of reaction to take place, there must be a change. And also, this must happen per unit time. What happened? So you will be also expected, like I said in the objective, that you will also be expected to calculate. And the formula that we use to calculate, or the expression that can be used to calculate, is given by the formula average rate is the change in the number of moles. Your exam can also ask you the mass. So in other words, which means you can have got rate rate equal to delta C or M or N over delta T. So I want you to not to say, oh, in the examination, they've only given me the number of moles. No, you can also be given concentration. You can also be given the mass. And what you have to remember is that it must change. And what happens during change is that during change, the reactants are being used up and the product are being formed. And grade 12, remember, this reaction is occurring at an open system. So the product cannot be converted back to the reactants because some of the things there will be going to be an interaction with the surrounding. So this is the reaction, the expression. Why do we have got negative? The negative is only applicable, grade 12, for when you are calculating the reactants. Why? Because during the course of the reactions, the concentration of the reactants it decreases while it's been converted to the product. So when all this thing happens, when you are moving mathematically from your final will be greater than your initial. And when you subtract, you are going to get a negative value. So this negative in the formula is going to subtract, to counteract the answer, and your answer will be in the positive value. So grade 12, remember, whenever you are going to calculate the rate of reaction, remember, your answer must always be a positive value. What happens if you write a negative value? The examiner can decide to subtract 1 mark, and we don't need to lose marks in the examination. We need as many marks as we can in order for us to pass and pass effectively. I said when we define rate is the change in the concentration of the reactants or the product. With the product, it's easy because during the course of the reaction, the concentration of the final will be greater than the concentration of the initial, and subtracting the two, you're going to get a positive value, and that is what we are looking for. Your rate of reaction must always be in positive number. Collision theory. What is collision theory? In order for the reaction to occur, this theory helps us to explain why this reaction takes place. In order for this reaction to take place, there must be 3 conditions that must be met. 3 conditions. Condition number 1, these reacting particles must collide effectively. And when they collide effectively, they must collide effectively with minimum energy. Don't forget what that minimum energy. This minimum energy, it is the activation energy that we have defined at the beginning when we were dealing with the objective of the lesson. And also, they must have got a correct orientation. What does a correct orientation mean? Grade 12, if I give you a pack of keys and I said to you, go and open the door, not all those doors will be opened by all the 5 keys. Only 1 key with the correct orientation will be able to open the door. The same applies to the rate of reaction. In order for the rate of reaction to increase, these 3 conditions must be met. Number 1, the particles must collide effectively. Number 2, they must have got a minimum energy. And number 3, the correct orientation. We are going to use the collision theory to explain. This is exam, grade 12. In your grade 12 question paper, they're not going to ask you to list the factors that affect the rates of reaction. No. You need to remember that according to the exam guideline, you are supposed to use the collision theory to explain. So don't expect grade 12 to get this question, list the factors that affect the rates of reaction. What are those factors that we're going to discuss? We're going to discuss the concentration. Concentration is only for solution. We are going to discuss the surface area only for solids. We are going to discuss the pressure, temperature, the nature of the reacting substance, and the last one will be the addition of catalyst. Now, let's discuss each one. I'm going to start with the surface area. Some textbooks call it the state of division. What you have to remember, grade 12, is that the collision must only occur for the solid, it must occur on the surface of the solid. So what must you do in order to have got higher solid? In order for you to have got higher solid, you need to higher reacting rights. You need to have got greater surface area. So what must you do in order for you to have got a greater surface area? The other method that is common in use, we grind the solid. Grade 12, remember, by grinding the solid, I'm not changing the mass. I'm just increasing the surface area. So what is it that you need to remember in the examination? Bullet number 1, which is very important. The reaction rate increases with an increase in the surface area of the reactants. What does that mean? It means with the minute your surface area increases, your reaction rate increases. And what causes the rate of reaction to increase is because you have got more reacting sites. So this is the explanation. I urge you, grade 12, you must answer this question in a bullet form. Why am I advising you to do it in a bullet form? Because if you can do it in a paragraph, you are going to miss some of the important words, and this results in the forfeiting of the marks. That I said at the beginning, we don't need to forfeit marks. We need to accumulate as many marks as we need. What do you need to write in your explanation? In the examination, by writing an increase in surface area, increase the rate of reaction. You haven't explained. What entails the explanation? Your bullet number 1, increasing the surface area. By grinding it, you are having more reacting sites. Once you have got more reacting sites, what does that mean? Increasing the reacting sites will increase the frequency of the total collision. And as a result, more effective collision per unit time, which will increase the reaction rate. So what are the most important things that you must remember? Bullet number 1, increasing the surface area increases the reaction sites. Bullet number 2, by increasing the reaction site, you are going to have got more particles with enough energy. And as a result, more effective collision will increase the rates of reaction. Concentration. Concentration, what is concentration? Concentration is the measure of the number of moles of dissolved substances. What are those dissolved substances? In physical science, we call it solute per unit volume. Same thing, it's a blanket statement. How does the rate of reaction increase? How does the increase in concentration increase the rates of reaction? Your explanation. What entails in the explanation? Increasing concentration increase the number of particles or the number of solutes per unit volume. Increasing concentration increases the number of solids or the number of particles per unit volume. As a result, there will be an increase in the effective collision between particles per unit time. Some textbook will say increase the frequency of effective collision. When you use this statement, increase the frequency of effective collision, because we have been talking about per unit time. So when you use this statement, don't add at the end per unit time, because frequency means the number of vibration per unit time. By saying frequency, you have already included the phrase per unit time. And as a result, the rates of reaction will increase. Temperature. What does temperature do? Same thing, an increase in temperature increases the reaction rate. But what is the explanation? What happens when you increase temperature? Increase in temperature increases the average kinetic energy. In physics, you have defined kinetic energy. And I've told you at the beginning, in order for the particles to collide effectively, they need energy. So kinetic energy is the energy possessed by a moving object. So the particles need to move. So in order for the particles to move, they need energy. And that energy is called average kinetic energy. What happens when that happens? More molecules will have minimum energy, or will have sufficient energy, which is equal or higher than the activation energy. Once that happens, you are going to have got more effective collision per unit time, or increase in the collision frequency per unit time. And as a result, your rate of reaction will increase. For the past, those three conditions that I've been talking about, you can see I've been saying an increase, the higher the temperature, the higher the rate of reaction. What does that mean? It means temperature is your independent variable and your rate of reaction is your dependent variable. What does that mean? It means if you don't change the temperature, or if you don't change the concentration, or if you don't change the surface area, the rate of reaction will not be affected. So in the examination, the examiner can ask you also to write down the investigative question. In your investigation, colleagues, learners, you must remember that you are supposed to have the independent and the dependent variable and the relationship. Again, as a tip, grade 12, the examiner cannot change both of them at the same time and ask you which one will increase the rate of reaction. So if the examiner does that, we call it is an unfair test. It's no longer a fair test. In order for you to have got a fair test, you need to have got one independent variable, and you measure your output, which is your dependent variable. The presence of catalyst. We don't add catalyst. We add catalyst, but we don't increase catalyst. So you can't increase catalyst. Look at now the wording that you're supposed to use in an examination. What does that mean? What is catalyst? I said we only deal with positive catalyst because we are only concerned here in increasing the rate of reaction. What is the definition of a positive catalyst? A positive catalyst is a substance that speeds or increases the rate of chemical reaction by providing a different pathway. Some textbooks call it an alternative pathway of lower activation energy. So what does that mean? It means once you add a catalyst, you are lowering your activation energy. And at the end, what the catalyst doesn't do, it doesn't change its shape. So whatever you started with it at the beginning, you remain with it. So you can be able to measure the catalyst after the reaction has reached its completion. Catalyst also doesn't change the energy of the reactants or the product. In grade 11, you have done exothermic and endothermic graph, where you were introduced with the concept of the energy of the reactants and the energy of the product. And because the energy of the product and the energy of the reactants doesn't change, as a result, the heat of reaction remains unaffected. So this is what you have to remember in an examination. What the catalysts do and what the catalyst cannot do. What the catalyst cannot do is to change the energy of the reactants and the energy of the product. What the catalyst cannot do, the catalyst cannot change the heat of reaction. What it can do, it can only provide the alternative pathway of lower activation energy. What do you do when you are given a question in an exam and you are asked to explain what is the effect of adding a catalyst? But not any catalyst will increase the rates of reaction. Each reaction will have got its own catalyst. So it means you must have got a suitable catalyst for each reaction. What happens when you add catalyst? Number one, it provides the alternative pathway. Alternative route, alternative pathway with lower activation energy. More particles. Underline the word more. In your exam, you leave more, you forfeit the mark. More particles will react on the catalyzed pathway that has been created, and as a result, more effective collision per unit time. What are the mistakes that learners do in the examination? In the examination, learners will just write effective collision per unit time. You leave the word more, you don't get the marks. You just said collision per unit time, you don't get the marks. If you just say particles will react with enough or you leave the word enough or sufficient energy, you also don't get the marks. These are the mistakes that year in and year out, our diagnostic report that come from DBE will always say candidates are unable to explain, or candidates are leaving the most important phrase in their answers when they write at the end of the year. So at the end of the year, there are ways that you must remember. More effective collision per unit time, or particles will collide effectively with energy that is greater or equal to the activation energy. The nature of the reacting substance. This one, I haven't seen it in the question paper where they ask you to explain, because there's nothing that you have to explain here except to know what is taking place. The rate of the chemical reaction depends on the medium in which the reaction occurs. You have done the states of matter in grade 10, where you have done the solid, the liquid, and the gases. So the rate of chemical reaction depends on the states of matter. What does that mean? Rate of reaction will differ depending on the medium, whether it is aqueous, whether it is organic, polar, or non-polar. These are the terms that you are familiar from, that you have learned in your grade 11. The reaction in which ionic and polar solution are involved, it will make the rate of reaction to be higher. In your organic chemistry, you have done organic reactions. And in those organic reactions, it involves covalent bonding. So the reactants that have got covalent bonding will decrease the rates of reaction, because it will require more energy in order for the reaction to take place, which is activation energy. Now, let us deal with the Maxwell distribution curve. Like I said, you are going to have got the graph in your examination. In the Maxwell distribution curve, there are only going to be 3 factors that are going to be examinable. It's temperature, concentration, and the catalyst. What is happening here, you have got T1. This is your T1. At this point, you have got particles that have got energy. What does that mean? It means these particles that are below the surface, they don't have got enough energy. So what happened when you increase the temperature? Grade 12, in the examination, you will be expected to draw these 2 graphs in the same axis. So what is happening here? When the temperature increases, what happened? The peak drops. And when the peak drops, it shifted to the right and it became wider. And you can see here, these particles with enough energy will increase. That is what we have been discussing. What does that mean? It means for the temperature T2, more particles have got E that is greater or equal to activation energy. And we have indicated that if E, which is the activation energy, it is greater or equal to activation energy, this will result to more effective collision per unit time. Concentration. I want you to notice the difference between the peak now. Because the concentration, it deals with the number of particles per unit volume. What is happening here? This graph, which is on top, is the one of higher concentration. And the graph below is the one of lower concentration. The number of particles, because a rate of reaction increases as a result of more effective collision per unit time. And in order for the effective collision to take place, those particles must have got enough energy. This one is the easiest one. Remember what I said when I explained the catalyst. I said, with the catalyst, what happened? It will never affect the peak. It will never do anything with the peak. What it does, it only shifted the activation energy to be lower, because we said catalysts provide the alternative pathway of lower activation energy. So these are the particles that have got enough energy in order to cause the effective collision, which is more effective collision. This is the graph that you have done last year. Like I explained when I was explaining catalyst, I said to you, when you add catalyst, the energy of the reactants and the energy of the product are not affected. What does that mean? In the middle here, you have got your delta H, which is the heat of reaction. What happens when you add catalyst, or when you are expected in the examination to draw on the same axis the addition of the suitable catalyst? You see what is happening? We start at the same time and we end at the same position. What happened is that the energy that is required, the activation energy, is now low. It was higher, but the minute you add catalyst, what happened? The energy that is required will be less than the one without the catalyst. When we were explaining the formula for calculating the rate, I said to you, rate of reaction is the change in concentration of the reactants or the product per unit time. So in the examination, grade 12, take note of the shape of the graph that you are going to be given. If you, by any chance, this graph is in your question paper, you must be able to remember quickly that, oh, this is the graph of the reactants. Why? Because when you start the reaction, you start with higher concentration. As the reaction proceeds, the concentration decreases until it flattens up. What does that mean? It means the concentration of the reactants is decreasing and decreasing and decreasing until the reactants have been used up. Once the reactants has been used up, the graph flattens. Why does the graph flatten? It means there's nothing that can be converted to form a product. That is the reason when we calculate, we said you must indicate, you must use negative. Why? Because the concentration starts at higher, goes down. When it's here, it's lower. Going down, decreases until that point, and your graph flattens. So in the examination, if they ask you what will happen when you add temperature, what happens is that your graph that comes will be coming below. So be very careful. I've seen one question when they say, why is the rate of reaction decreases as the concentration decreases? It decreases because once the concentration becomes less, you are going to have got less effective collision. The minute you have got less effective collision, your rate of reaction will decrease. This is the one for the product. The same, I want you to notice where the two graphs start. The other one for the product, it starts up. Because when you start with the reactants. You don't start with the product. That is why your graph here is start at 0. It's starting at 0 because at the time the reactants are converted into the product, you don't have got the product. So as soon as the reaction starts to continue, the product are being formed. And as a result, you are having here the product are increasing. They cannot keep on increasing. They will also be limited by the reactants, which bring us to what you have done in grade 11, which is the limiting reagent. So what does that mean? It means your reactants are the limiting reagent. It limits the amount of the product that is going to be formed. As a result, at this point, your graph becomes flat. What does that mean? It means you don't have got no reactants that are left that can be converted into the product. And as a result, the rate of reaction in this point becomes 0. The reaction has stopped. Why the reaction stops? The reaction stops as a result of your limiting reagents being used up. In the examination, they can also ask you, what does this part mean? And you must explain. You cannot say, oh, at this point, the graph flattened. You haven't explained. The right explanation is to say, at this point, the reactants has been used up. So once the reactants has been used up, the rate of reaction will become 0. It cannot increase, it cannot decrease. Don't make a mistake of saying this is equilibrium. I indicated at the beginning that it is not equilibrium because this reaction are occurring at an open system. And also, once the product are being formed, they cannot be converted back to the reactants. And these are what we were explaining. And all the two graphs, grade 12, they're not a straight line graph. The fact that they're not a straight line graph, it means the gradient, which is the rate of reaction, is not constant. So the gradient, which is the rate of reaction, will keep on changing and changing depending on the amount of the concentration that you are having. So as the reaction starts, it is faster. Why is it starting faster? Because you have got enough reactants. And the more the reactants that you have, the more effective the collision that the reaction will take place. And as a result, your rate of reaction will increase. From the graph, the fastest part shows that the gradient of the graph is steepest. What does that mean? It means the rate of reaction is high. When it curves and become flat, it means your reactants are being used up and the rate of reaction is completed or it stops. Grade 12, thank you so much. These are some of the activities that we can go through quickly. This is the one way to show that you have understood, but I know when you have got time, you are going to use your previous question paper and be able to answer this question, your question 5, grade 12 chemistry paper. And thank you. I hope you are going to use what we have done today during this lockdown time to revise and go through it until you get the right answer. If you can't get the answers, your teachers are there to help you. I'm going to conclude to you grade 12 by saying, in order for you to pass your physical science paper 2, you need to practice effectively. And not effectively only, you need to practice more effectively. By practicing more effectively, you are now increasing your chances of increasing your level, which will lead you to distinction. Thank you so much, grade 12. Have a good day.